and welcome to another Mean 315 Principles of Thermodynamics auxiliary lecture. Okay, so we've already had one auxiliary lecture on working with English units, right? So I've hopefully appropriately titled this one as Working with English Units Continued. And the basic idea, or the most important message to get in terms of working with English units, particularly for thermodynamics, is the following. Okay, so the key, right? The key to working with English units is the following. You have to know what conversions are provided in your textbook. So your textbook has a whole list of conversion factors that are available to you in the back of the book. And I am going to try and see if I can do this with my iPad the best that I can. Let me see here, if you just bear with me for a moment. And if we go to here, and if we go to here, and then we go here, and then here. Okay, I think I did it. Okay, so what you will see is, if you look very, very closely, right, your book has a whole bunch of conversion factors that are listed for all different kinds of things, right? So you've got, for example, acceleration, and area, and density, and energy, right? So let's focus in on energy. And you'll notice at the very top that there's two additional columns that are listed for you. There's a column that lets you go from metric to metric, and then there's a column that lets you go from metric to English. Okay, so let's take a look, for example, and say under energy, see what some of the conversions are, right? So here is a conversion to go from kilojoules to BTU. Good one to know. And then the very next one is, just back and forth, BTU to kilojoule. But now look what else is listed. There's some additional units that are listed there. There's PSIA to cubic feet. It's kind of a funny unit. We will get to that later on in the semester, why that's important. And then there's pound force foot to feet, right? Now that's an important one, and one that'll come up when you're dealing with things like torque and such. So if you are, for example, calculating the torque of an electric motor, and you have, for example, torque, which is given to you in pound force foot, right? And you want to convert that into BTU, well, you can just use this conversion. 1 BTU is equal to 778 pound force foot. And then there are some others, such as BTU per pound mass into feet squared per second squared, kilojoules per kilogram, right? Kilowatt hour into BTU. All of these will come up most likely throughout the semester, right? So it will behoove you, if you take some time, to take a look at this list of conversion factors that are provided to you in the textbook and just become familiar with them. Just look at some of them. You may not necessarily realize yet how you use them, but at least if you become familiar with them, then when you see a unit, you might think to yourself, oh, I bet that there is a conversion factor in the back of the book that will help me do this. Another good one to pay attention to is power, right, or heat transfer rate. We've got a bunch of conversions here for kilowatt to BTU per hour, and horsepower into pound force feet per second or BTU per second. and kilowatts, so on and so forth. Okay, so that's the first thing, right? The first thing to working with English units is knowing that you want to essentially be sure to know what conversions are provided to you in your textbook. Okay, so now it might also be helpful if we can actually show an example that will let you actually implement this. So let's go ahead and do an example. And so in this example, what we will do is we'll look at a windmill. Okay. And so of course we have our windmill system, right? And I will do my best to draw this. But you have, for example, the windmill pole, right? And it's anchored into the ground, of course. And you've got the generator that sits atop of it, right? And then there are blades that are connected to it. And you have wind, right, that blows, and the wind spins the windmill, and the windmill spins the generator shaft, and the generator then produces some electricity, right? That's what we're after, is this W dot electric. And the windmill takes the kinetic energy, the velocity of the wind, which, for example, since we want to understand English units, would have units of feet per second, right? And it would be flowing at a flow rate, which, again, in English units, would be pound mass per second. Okay, so how do we analyze this, right? So we need to first of all come up with our governing equation. So to do that, we realize that our kinetic energy, right, Ke, and I'm going to call this Ke dot, right? So this is the kinetic energy rate, and so this would have units of, say, BTU per second, for example. Again, we're doing this in English units. And of course, the kinetic energy rate is just 1/2 times the mass flow rate, which has units of pound mass per second, times the velocity squared, which is, of course, going to give us units of feet squared per second squared. Okay, so when I do a unit analysis of this, right, we have on the left-hand side BTU per second. And then on the right-hand side, we've got some really goofy units of pound mass, feet squared per second cubed. Okay, so if we leave it like that, that is going to probably create some confusion for us because we're probably not going to find a good unit that will let us go from pound mass feet squared to per second cubed into something like BTU per second. Okay, so instead, what I'm going to do is I'm going to leave it in the same units that it is written in the equation above. And so I'm going to say that this is pound mass per second, and then feet squared per second squared. And let's see what we get. Okay, so now if we go to the back of our book and we look at the conversion factors that are listed there, and if we look under the category of energy, what we'll find is we will find a conversion that says 1 BTU per pound mass is equal to 25,037 feet squared per second squared. Okay? So before we actually use that, let me show you where I found that in the back of the book so that you all can see exactly where that comes from. Because again, remember, the key to working with English units is know what conversions are provided for you in your textbook. So let's go look at that real quickly. And if I can remember this, okay, I'm getting better at this. Okay, so first of all, we come over here and we find energy. There's energy, right? And then we come over to the English to metric. So we come on over here and we scroll down the list. We just look and see if we can find something that looks familiar that we have it written in. And behold, we've got something here that says feet squared per second squared. Well, that's exactly what my velocity squared is feet squared per second squared. And so this is where I then get that 25,037 feet squared per second squared is equal to 1 BTU per pound mass. Okay? So we can use that and go back. Okay, how slick I, oh, no, not so slick. Okay, there we go. See what happens when I get cocky. Okay, so I have now, I just wrote that down. 1 BTU per pound mass is equal to 25,037 feet squared per second squared. Okay, so now I can substitute that back into my expression that I have above, right? So this can basically go right back up into here, okay? And so then what I get is the following. My kinetic energy rate, remember I'm doing this on a rate basis, so my kinetic energy rate is equal to 1/2 m dot, which is units of pound mass per second, getting ahead of myself, times velocity squared in feet squared per second squared. And now I introduce my conversion factor where I say that for every BTU, so if I have now a BTU second squared, this is equal to 25,037 That 3 doesn't want to come out very well here. There we go. 25,037 feet squared pound mass. That's my conversion factor. And so right away now what I see is that my feet squared cancels, and something else pretty cool happens. My pound mass also cancels, and my second squareds cancel. And so now my kinetic energy rate is exactly in the units that I want. It's in the units of BTU per second. Okay? Pretty slick. So don't let English units scare you. Again, the absolute key is that you know what conversion factors are available to you in the back of your textbook. This will certainly help you become very proficient with English units, and you'll become as good, if not better, with English units than you will with metric units. This concludes this auxiliary lecture, and if you have any further questions, feel free to contact me. Thank you.